Okay, hello everybody. Welcome to the first official Whippany River Watershed Action Committee meeting of the year. We did hold one last month, but that was for a special presentation of the American River video. And so we didn't have pizza, so it's not official until you have pizza. Thank you for having it, sharing it with us. But today we also have, it's very special because we have the Unity Charter Middle School students giving a presentation on the Whippany River Water Quality Study. And I've been hearing a lot about it from Jed Karsich and your teacher, Jeff Rosick. And so I'm very excited about it because the river belongs to us, and we want to know how to take care of it. And you guys are doing an excellent job in doing that. Without further ado, I'll introduce you to just first name, Paul. You can wave your hand with you by calling him. Daniel, Ava, Rishi, Ravi, Charles, Pedro, and Julie. So without further ado, here are the students of the Unity Charter School.
Thank you. All right, so today we're going to be presenting about the effects of road salt on our waterways. From Unity Charter School on the 8th grade field study, specifically with the river. Introduction. So this is our testable question and hypothesis. The effects of road salt can leave. I'm sorry, guys, I'm nervous. The effects of road salt can leave the ecosystem of a stream in dire condition. Going into this project, our testable question was, how does sodium chloride affect other factors that affect the ecosystem? Our hypothesis was that sodium chloride will affect all the factors in a negative way, impacting the ecosystem. Some factors that can get affected are the pH, nitrates, dissolved oxygen, turbidity, and phosphates in the water. Sodium chloride, also known as road salt, can be detrimental. But if the community takes action, we can save our waterways. Our class has been going down to the Whippany River every few weeks and have been taking samples. We are doing this so we can help our community while learning about the ways we can protect the environment.
The overview. Over the course of 3 months, we collected data from Whippany River through a series of tests. During the first test in October, we collected water samples and then used a water tester kit to find our collected data. We then briefly organized and made sense of our findings. In January, we continued to compare the difference in our findings based on the road salt, sodium chloride, used in between our data points. We then came to conclusion based on our findings about the benefits and drawbacks of the road salt, sodium chloride.
Phosphates, findings and what it means. We found that the Whippany River contained 2 ppm of phosphate on January 17th. The acceptable amount of phosphate is 1 ppm. 2 ppm of phosphate is not necessarily bad, but is not very healthy either. Anything over 1 ppm of phosphate may interfere with the water treatment process and can stimulate aquatic plant growth. This may lead to the plants taking over the river and creating more dissolved oxygen than the normal healthy water.
Sodium chloride, findings and what it means. Sodium chloride, more well known as road salt, can affect the other factors of the water. It can cause both private and public property damage by dissolving soil and can kill the amphibians and fish. That being said, the normal ppm of sodium chloride in rivers and lakes is 1 to 100 ppm. We found that in January, the sodium chloride level was 201 ppm, which is well over the healthy level of sodium chloride that should be in the water. This means that the amount of road salt can temporarily destroy the ecosystem, or in the worst case scenario, cause irreplaceable damage.
Nitrates, finding and what it means. In October, we looked at the nitrates of the Whippany River and we found that there was 5 ppm.
The ppm levels stayed the same when we tested them a couple weeks ago in January. This shows that the river is staying on average. If the ppm raises, then the animals in the water will have a difficult time of living and find their fins and colors will start to fade in the water. This is why we need the ppm to stay at a constant average so that organisms can continue to thrive in the Whippany River.
Dissolved oxygen, findings and what it means. In the Whippany River, we found that the dissolved oxygen levels were 4 ppm, which is lower than it should be since the average is 5 to 6 ppm. Now, although it won't drastically change anything, it will put a bit of pressure on the organisms by giving them smaller amounts of oxygen.
Turbidity, findings and what it means. During November, we found that the turbidity level was 20 ppm, which was 10 units higher than what it should be. Subsequent to this, we found that the levels had dropped to 0 ppm on January 12th, which was a very good result. We concluded from the data that the sodium chloride road salt had a beneficial effect on the turbidity level.
We found that the coliform was present in the Whippany River. The fact that there is coliform present in the water, which could potentially contain diseases, means that the water could be harmful for marine life as well as humans. In October, we found that the coliform bacteria was present, and we got the same answer when we tested it again in January. The healthy amount of coliform would be 0 or less than 2.2. If an MPM text is used, the real world application is to see if the water in the Whippany River is contaminated. The ecosystem is affected because the animals that drink from the river will get disease.
pH, findings and what it means. We found that the levels of pH had decreased since October. While it was a good pH level of 8 in October, we found that it was just a 6 in January. The preferable pH level is anywhere between 6.5 and 9, meaning that it was good during October, but too low during January. We believe that this is most likely due to the pollution in soil or water, which could cause decrease in acidity. This is likely because we went down to the river, the soil on the riverbank had a large amount of litter. However, the decrease in pH could also have been caused by snow melting and water draining into the river. Considering that the water in the river has about the same acidity as milk, which is not good, if it continues, the acidity will get even worse.
Overall analysis. Throughout the months, our classes learned many things through a series of experiments and labs regarding the river. One big takeaway that our classes found was how to test the water samples. Whether it was a stream watch coordinator, our teacher Jeff, or even a classmate that had maybe done similar experiences before, there was always somebody there to teach us something about testing water. Testing turbidity, pH, phosphate was a learning experience for each and every classmate.
From October to January. When we first went to the Whippany River in October, we saw that the levels were perfectly fine and normal. When we went in January, we saw that the levels were higher or very different compared to when we went before. It shows that most likely due to the salt in the water, it causes the water's levels to differ. So here on this graph right here we created, it shows the phosphates, nitrates, and dissolved oxygen from October and January, dark blue being January and light blue being October.
October to January. October to January in pictures. So in some of these pictures, we were looking at the same data that we were testing before, starting in October, then leading to January. We went once every other class to test the water, and then those were the pictures we saw.
What's next? We calculated the amount of sodium chloride in the river by getting a water sample and dipping the sodium chloride in, and it said 4.6. Next, we used a graph to determine how much sodium chloride is in the water if we get 4.6 on the strip, and it was about 201 ppm.
So, on this link right here, it helped us measure the salt measurements and whatnot. So we use this to find some of our data. Pushing our research further.
Through this project, we have found lots of data to help the Whippany River and dive deeper into what belongs in a healthy ecosystem, water and rivers. Doing this as eighth grade class helps us recognize and learn more about the environment we live in. We're going to push our research further by using this data to help with other experiments.
Thank you for your attention and time.
Yeah.
Yeah, somebody said how often you guys run out, and I didn't hear that.
It was every other class,
Like every couple of weeks.
every,
So like in October, you went out like twice in October?
Yeah, so in October, we went once, and then we were supposed to go again in 2 weeks, but then there's something that came up.
Like the weather.
So then we skipped, yeah, so then we skipped another 2 weeks, and then went again in early January, and then went again late January.
Did you take into account the days that the town salted? The dates of the salting versus the dates of you taking the test?
No, not really. We looked mostly.
That's something that maybe you could, you have the dates that you took the test, maybe you can contact the, DPWs of each of the towns and see when they salted, and maybe you can see another correlation in that.
I think that's why we started in October, before, the road salt.
No, I understand, but I'm just saying that, see how quickly salt does get into the.
Yeah, absolutely.
Yeah, and obviously we did notice something, because in January when it was snowing, the levels started going a little bit crazy and stuff, so you could make an assumption there, because it's all that we know.
Right, I'm just saying, but if you get the dates, then you have at least dates of you, from the Weather Bureau, you can get the dates of snowfalls. You know that's when they had salted anyway, right?
Yes.
And where in the river exactly did you take the sample?
the one near, a park, right by Bergen Park.
Granby Park.
Oh,
Granby,
Granby Park.
oh, Granby. And that's where you go consistently.
Yeah, yes, there's a road up there that goes, also like the State Board Center,
Okay.
top of the hill, so.
Tell them how you get there.
You-
How do you get there?
So we walk from our school, we go around and through the graveyard, and then we just walk down the road. And then we make a few turns and we're there, and we just have to go straight through the park, and then we're right there at the river, and all we gotta do is go through the gate. Which was over. Just had to be.
And are you done doing this?
No, we're gonna keep on doing this throughout the rest of the year, continue to measure it.
Explain to them what you're gonna do with the fourth grade.
Right,
So,
so fourth grade, we're gonna combine, and then with the fourth grade, we're gonna look at our data, their data, what everything we collected, and then just draw conclusions from that.
and then also with the
When we went,
organisms.
when we went to the school conservation, and we did the
Yes.
river. When we went to the river, what did we do there? And what did we
So-
learn?
When we went to the river at the school conservation, we learned about the true, like, about the animals inside the water and the little bugs that are around the water. And we went into the river and we took, not samples, but we took a few bugs, found out which bugs they were, and then put them back in the water. And then after that, we went back into the classroom and we learned more about what those bugs were and what they do. So,
And then we're gonna do that in the river. And then, I don't know if you guys know that part yet, but. Yeah, oh yeah, and they're gonna do leaf packs
yes,
and bring the leaf packs back for fourth grade. It's a little too far for fourth grade. What is a leaf pack?
it's basically just a sample of leaves that we take from the river and we put into a pack. And then we go back later and then find out.
It helps collect the organisms, so, and they're safe, and then we can transport them back.
We use market bags,
Yeah.
like the net bags from Lions.
Sorry. Did you find out that the bugs were beneficial or not beneficial? I'm just curious.
Well, obviously, the bugs make an impact in the food chain and everything,
Okay.
but, we did not take data for if they affect the waterways specifically. But we did find that organisms can be affected by the road salt, which makes an impact. And then, one more thing I want to add was, our first time we met with a stream watch coordinator, Sam Davis. We went with him and he taught us, how to take the water samples specifically, which was another experience we, took in and used to find the water samples.
And that's the next layer that they learn, that have their indicators for the health of the river. And then they'll come back and teach the fourth graders about it. So by the time the fourth graders get to eighth grade, they'll be ready to go in the field and do this.
I'm sorry I missed the beginning. I had another meeting, but, are you in environmental class at the school? I mean, what class are you
So this is science class,
in? Okay.
and our school is, we're a sustainable school, so we follow all 21 sustainable goals. So in every class, it's integrated into what we learn every day, sustainability and how it works in the world and how we can make a change. So this is our science class, and we are just trying to make a change.
Yeah, and Unity is kind of known as like a science-focused school. Our science program's very strong. Thanks, Jeff. But yeah, the eighth grade science class is always fun because we gotta take field trips, but it's a big part of Unity.
Great, thank you.
Program, to communicate and take sustainability, other than the water aspect, are there other areas that you
So we do
investigate?
So we do a personal learning plan on sustainable development goals. So right now, today, actually at school, we just learned about the new PLPs, personal learning plan that we're doing. And it's about cultural, like protecting people's culture and not changing it and having it original. So we are researching about social media and how it can affect cultural preservation. And that's one of the sustainable development goals. That's just one of the things that we do.
We do it a total of 2 times a year through the trimesters. And then, so last PLP was, we found a town in the whole US, anywhere, and we researched about it, found like, we choose a topic, so it's like poverty or,
Education or pollution.
violence, education, pollution, any of the above, and then use that to study about it and make a project about it. We also have done about companies, about how they're affecting the environment, pollution wise and stuff. Do a lot of stuff with,
That's great.
Good job.
Good job.
Your PowerPoint presentation or is that?
Yes.
Yeah.
I'm curious, like, talking about the road call and like which of the parameters that you guys measure you think most suitable to the road call? Like, I guess in the sodium chloride, has something that you were focused on?
Yeah.
And I just wanted to see that again, to see what, I didn't really know what the impact was.
For the first one for it. So, chart. So like I said here, this is what we found from October to January. So, these are all, aspects that add up to sodium chloride and there's like, an impact on the environment.
Yeah, so Paul just said that sodium chloride has an effect on all these things, and all these things have an effect on different organisms and different things that live in the water. So phosphates change throughout time, nitrates stay about the same, and then dissolved oxygen decreased a lot. And then that led to different organisms possibly dying off in the future, or some of them thriving in the future.
And then did you actually measure those for sodium chloride?
Yes.
Can you show what that one was?
So,
Yeah, it was the main topic, sodium chloride, like what we were focused on.
Which is road stuff. So it's like when it's down, so the snow melts and it doesn't let the cars slip in the roadways, and it eliminates black ice in the road, snow, normal ice.
Did you look at any alternatives to that stuff?
We
To see
did
if
look
it
at,
changes, like if there's a more natural.
so we did look at, so like Jeff, he has a bunch of dogs. He has a lot of dogs and he goes for rescue. He's part of the rescue group. And when the dogs walk on the side of the road, they're all limping after like a few minutes because it burns their paws. So we looked at a more pet-friendly stall
Okay.
that would eventually help pets walk on the side of the roads, and it wouldn't be as bad when going into the runoffs and.
But you have to suggest that to the town.
Yeah. Just one question about this too. I see the measurement in January, but did you get a measurement in October for that?
Zero.
Zero. Yeah.
It was zero, because they didn't lay down road salt because it didn't snow in October.
Oh, so there actually was none, and it went from 0 to 0.
Yeah, because like I said, the river is like right next to this like, road on a hill, has a very like steep side. So, I mean, I'm sure they lost that road or like when the rain falls, a lot of water comes down and it'll rip all the salt down, like directly into the river. It's like super close to the road.
Yeah, that was actually amazing. Is that line there, does that represent your measurement?
It represents general measurements of like, throughout, like, when the snows and stuff, the water. And, another thing we noticed, which I think said earlier, was since the river's right next to a park, it's directly, there's just a gate, separating them. But there was a lot of litter as well, like just walking on the shore of the river, a lot of like grass, metal, that kind of stuff, which definitely can make an impact in pretty well.
Did the litter on the side come from the river, maybe when it's like,
Yeah.
closed?
It's possible, but also there is a soccer field and a baseball field. So it could just be people's parents, littering, bottles, soda cans. But it also could just be from the river, get caught in the river and then.
Any hypotheses about how long it will take to come back down to 0?
Well, over time, so obviously last year in 2024, it snowed in February, I'm sure. So obviously it fades over time, the sodium chloride in there, it gets like sifted out with all the rocks and sand and stuff. But, there are ways of reducing the sodium chloride, which is like, using like, ways of testing and then trying to clean it out. Like sort of dilute it.
Any other questions?
Yeah, can you put up the slide with the photograph that went by so fast? I don't want to see again.
This is our other classmates, just taking samples from the water, leave there, and mine.
And they don't know yet. The other, they're pretty know the different things, so they're gonna do year-over-year comparison. Once they collect all their data. Okay, they're multi-layered.
It's only our.
You don't know even. That was the beginning of their adventure with this right now.
Okay, how many years of,
Oh, wow, Jeff and I, it's probably 4th year, but the first year we only were able to go to one.
yeah,
The second, each year we got more and more brave and more and more involved with it. So last year I would say but we have the most data points that they're going to be able to compare. And they put it on, they don't know yet either. It goes onto the website, the New Jersey Salt Watch website. Oh, they do now? Oh, that's great. Yeah. So it's, oh yeah, that's right, the link was on it. So they share it with the community at large, but there's other places that are doing it as well. So then other citizen scientists can see, if there's similar results at similar times of year in different, each different areas of the state.
any plans to introduce it to the town? Town to reduce the town super.
Sure. We are planning on going. Remember,
I've had one student come present before, but this year when we have two answers the data, they'll be coming this year.
Okay, thanks.
Any other questions?
Did you find any like tiny bits of plastic in that litter?
Yes, as you can see, looks like a bottle cap right here.
Yeah.
And if you just keep on looking at the photos, you look closely at the ground, you could just see things, litter, glass.
Glass?
Could be a piece of glass right there also in the water, listening in there. So there's a lot of things. We also looked at organisms in the water, with, Davis, the, Dream Watch coordinator. We found like, water skippers. I think we found a couple of other, small organisms.
Is that good? Is that positive?
Yeah, yeah. It shows
Was it a
that,
little
yes, it shows that,
amphibious, animal?
yeah, it shows that living is like, they can strive in it.
Okay.
They're healthy and moving around well.
Right.
So that's a good sign. You want to have a question?
I do have a question about the organisms. As the weather got colder, did you start to see less and less organisms, or these organisms just kind of year round and spread them, on the water?
Well, we didn't take, trying to find them in January. We probably wouldn't get out, but we didn't
That's like
specifically.
their next step.
Is there a different issue that I don't know if you guys covered this, we did the issue with the trash, nothing to do with the weather, but possibly, perspectives of humans and their needs by the river. Did you notice anything there? Did you guys talk about that at all? Maybe everything, if there were people maybe living on the river? Did you guys?
Oh, yes. So we seen a lot of scraps of clothes, ripped up clothes, shoes, food. So there was a bunch of signs of, people living in there. Well, adding on to that, obviously there was stuff in the section that we looked at, but outside of school, some known I have gone to cleanups for WRWAC, and we found literally there was a suitcase and a tent of clothes, obviously a lot of bottles and stuff. So we have seen signs of it throughout the river.
So that's just another layer, right?
Yeah.
It's taken away from it, really.
Which can affect the water.
There was a lot of cloth, just laying around, stuck in the trees, bushes. Yeah, I was there recently. It was bad. If you just go through it a little bit, you keep on going along the river, and you just look up, you see a bunch of clothes.
So there's people in need.
Yeah.
Right, that's what we're finding out.
We didn't even see any people, but there was nothing.
Well, thank you. Thank you.
Thank you. Well, thanks for a great presentation and I'll follow what you.
What was your first slide? Did you have your logo for the school?
Oh, no.
I'd love to get a picture. That's what. The teacher likes to be on the phone every
Yeah.
Yeah.
Yeah, do it for a while.
Right.
Wait. Wait, no, I got let me just turn this off.